For this example, we want to solve an inequality that involves an absolute value. We have the absolute value of 3x minus 6. We want to know when is that strictly greater than 6. So let's recall what we know about transformations and graphs of the absolute value to get a picture of the values that we're looking for. So this function, f of x, equals the absolute value of 3x minus 6. If we just take a look at the left side, this is the absolute value function which has first been shifted to the right by 6 units, and then it's been horizontally scaled by a factor of 1/3. So this absolute value function, which starts off, I'll just have a rough sketch over here, like this, has first been shifted to the right. So the vertex, which was at 0, 0, now winds up at 6, 0, and then we scale it horizontally by a factor of 1/3. So we smush it in closer to the y-axis, and now this point that was at 6, 0 gets moved 1/3 of the way closer, so it winds up at 2, 0. And so what we want to know is what are the values of x that make this absolute value greater than 6. So let's just say here is y equals 6. And I put a dashed line here because we have a strict inequality. So what we're looking for, what we should be trying to identify, are the values that I'm highlighting in blue and blue. So there's an interval of x values here and an interval of x values here where the absolute value is above the horizontal line y equals 6. So let's first identify where these are actually equal to each other. So these points right here that I've just circled in blue. And to find where the absolute value graph intersects the line y equals 6, well, that means we want to figure out when is the absolute value of 3x minus 6 exactly equal to 6. And recall what we know about absolute values, that this means this is going to occur when the expression inside the absolute value equals 6, as well as when the expression inside the absolute value is equal to minus 6, because when we take the absolute value of that, we would get positive 6. And so solving the first equation on the left, we add 6 to both sides, and then we divide by 3. So this tells me that over here, this point corresponds to x value of 4. That's where the two graphs intersect. And solving the other possibility, we again we add 6 to both sides. That gives me 3x is equal to 0, and then we divide by 3. So I see that x equals 0 is the other solution where these two intersect. And so that means this other point occurs exactly where these two graphs cross the y-axis. So now what I see is I don't want to include each of these points because we have a strict inequality over here. And so since we have this strictly greater than, this means I'm going to go all the way out to negative infinity up to x equals 0, and I'm going to exclude that. And then we have some values of x where the absolute value is below the horizontal line y equals 6, And then when x equals 4, they're equal. So I exclude 4 because I want strictly greater than. And then for all of the values of x that are greater than 4, the absolute value graph is now above that horizontal line. So by sketching a picture and thinking about how we've transformed the absolute value, it's really helpful having this picture to identify the intervals of x values where the absolute value is above y equals 6. So here would be our solution.